Okay, my advice too, if you want to stop the program, is just, instead of trying to use that run to cursor, just set another breakpoint if you want to stop somewhere. And see here, green means this is new code, so shows you the areas that are updated or whatnot. But yeah, when you're debugging, it's, just don't use that run to cursor. It's just too buggy. Just again set under the breakpoint and hit run like I used to do with Visual Basic, and that'll get you back. Here's me using printf with size of. Now you're just look at these various variable sizes here for ints, shorts, longs, floats, doubles, unsigned, bools, characters, etc., and boolean arrays. But notice here, since I'm using printf, I got to cast it. So what you see here is me typecasting it into an integer, because apparently printf doesn't like working with anything other than integers. So that's a typecast. I'm also apparently printing the address of some of these variables too. Let's see. Freaking breakpoint and run the motherfucker. Okay, so you can see, kind of what it's doing, the size of the various, arrays and individual elements. What? Bool is 4. Variable f is an unsigned integer. So, anyway, but okay, and anyway, these are addresses, but these addresses are going to be in integers, not hex. Later on, we change our display mode to hex, so you can actually, we do right here too. Cout version. What the hell? I don't know what that was. I don't know what that was. But let's see, cout version. Damn it. Get rid of that. Variable A. Variable A. I don't think this is in hex. Find the address up, but I don't think it's in hex. No, it actually is in hex. Huh, that's interesting. Because this isn't in hex down here. But cout, I guess, will, because remember, printf, it has to be an integer. So, where cout will actually print the addresses in, in hex. So by default, so that's what's kind of going on there. Okay, here we're using logical operators, not bitwise. In fact, none of my books really covered bit operators at all. But let me set another breakpoint and then hit run. And I used to do that in Visual Basic all the time. And that's a little more reliable, at least. So, logical operators, you know, A and B are 1. A or B is 1. You know, here's what A, B, and C equal. So, now A and B 0 now, since you set 0, A to 0, and or will be 0 over here too, so I don't need to tell you that. Let's see. Okay, by the way, this orange bar down here means you've got code running, you know, whereas a blue bar means there's not code running. Okay, let's go ahead and just run all this shit to the cursor. Okay, to the switch case and loop section, so we can take a look at the output here. Okay. Alright, so let's see what it printed. Now, we're dealing with floating point data types in this section. You know, A equals and A and B equals this, and we defined those earlier, you know, in the program up near the top of the main statement. And then we're going 4 variable float 4 variable float 4.025, and then 8 variable float 8.625. C equals 159 variable float 159.18. Okay, so what code is responsible for that? Now, we started like here, you know, you can see what A and B initially were, and, you know, we're just defining C, you know, which again I assume is another integer. That's what's irritating, is you can't just hover over it and have it tell you whether it's an integer or not. But it is. A, B, and C are integers. And variable D, you know, you can see up here, variable D is a float. And I assume that you can bookmark areas in this program too. I don't know how you actually do that though. I used to bookmark shit in Visual Basic a lot. You can't just right click on it. I don't see any bookmark toggles. I know it has bookmarks in it. I just don't know how you set a bookmark. And you might not be able to. Maybe you can't do that when a code is being debugged. I don't know. See, here's bookmarks right here. T. Okay. Well, anyway, there's bookmark flag. I guess that's what it looks like. Anyway, okay, but basically, you know, this is a data casting section, so, you know, that first C out, you know, saying C equals, okay, variable float, whatever that's supposed to mean, variable D. Okay, so, you know, we're printing C out to the console and variable D out to the console. But C equals C and variable D, you know, which is a floating point number, equals that. That's what I'm saying. That variable is a floating point, and that's what it equals. Okay, so first statement right here, C equals 4, the floating point equals 4. Damn it. Then I assign variable D to equal A divided by B. A is 69, B is 15. Those won't evenly divide. So that's what it's showing, is that even though this is a floating point variable, it's performing an integer calculation, because it'll divide about 4 times, but it'll have a remainder of 9, okay? So it should be 4 point something, but it's not getting that. You know, it's performing this operation as an integer value and assigning that integer value to the floating point number, even though it's still a floating point format. Okay, and we do have more data types than this too in C. I mean, in Microsoft, you know, you got like, you can go to a lot bigger numbers. You know, I assume you'd have access to the decimal data type and the, you know, long or double type, and they can go to enormous values these days. And the decimal data type's better if you're working with currency too, because floating point, you know, can, you know, once you start getting to the limits of its precision, can start to generate errors. But again, when you're well within the limits of its precision, you know, like it's a, you know, 20 bits or you know, 20 bits of precision, and you're only using 10 of them, I mean, it should be, you know, you should be safe. You know, if it's 60 bits of precision and you're only using, you know, 40 bits, you know, you should be safe. I mean, you know, even if you're working with currency. But anyway, it's neither here nor there. It's just some compilers will interpret, though, the different formats differently. So, but then again, some compilers probably don't have Microsoft decimal type, you know, which is the best to use for currency, because that can represent a huge decimal number. It's not floating point, it's decimal. So, but anyway, that's just an aside. But the point is that, you know, okay, you know, this is rounding off, you know, this value basically, and assigning it to our floating point number, and that's what we're, you know, seeing here. Okay, but if I go now, variable d equals, you know, variable d equals variable d plus 0.25, so 0.025. So now, you know, now when we do that same statement again, okay, you know, it's giving us that result when we run that same cout statement again. You know, but that's because it's not the result of a calculation, you know, this cout statement again. But it's performed a calculation on itself, so it's still a floating point value. It hadn't like changed to an integer or anything, and it's not going to do that because it's reserved in memory. That's why you have to declare these. You know, at the start of the program, this goes into a, you know, into the stack or whatnot as a variable this type. I mean, it's not going to change. That type will never change. But at any rate, then you go cout, you know, equals variable d again, okay, and that's what we saw up there. Okay, fine and dandy, it's not surprising. Okay, now I'm going variable d equals variable d plus float a divided by b. Okay, by converting a variable to float, that forces the calculation to be float rather than an integer calculation. So, basically the next statement should show us a more proper result, you know, for a divided by b. So, you know, it's saying, you know, c equals 8, and variable, I don't know why c equals 8. Okay. Okay. Yeah, well, c is irrelevant because we're dividing a and b. So again, it should have produced 4 point something, you know, as the output. So, and then here we're casting variable d into an int and putting it in C. Okay, because we know variable d we know variable d, you know, as a result, coming out of this operation, is definitely a floating point. Okay, floating point number, but we're casting C, it was 8 point something coming out of here. Yeah, because I said, anyway, we know it was 8 point something coming out of there. Yeah, because if we said variable D, here equal like 4 point something. Well, this is our first fucking... Man, I hate not being able to see the goddamn window at the same fucking time. I hate having to toggle back and forth. Okay. Like I said, this is our first statement. And we're incrementing it, and like I said, that should be equal to 4.25 coming out of here. So that one is 4.25. I'm going to try to stick this motherfucker up here somewhere. This is just ridiculous. Okay, so equals 4, and then 4.025. Is what this statement, is doing. But then we're saying variable D equals a floating point, operation. So it's going to override its, well, no, it's, okay, it's plus equals. Okay, well, I shouldn't have done that. Okay, so we're adding to the value we had here, we're adding the result of this division to it. So this really isn't telling me anything right here. This isn't a good example. Because it'd be better to do that same thing again. I mean, it's clearly working, but it still would have been a better example just to get rid of the original value instead of adding it to itself. So, but at any rate, it is casting that, because if I didn't cast it, just did A divided by B, it still would have just added 4 to it, so it'd be 8.25 instead of 8.625. So, I mean, it's clearly working. It's just not as clear as it should be, because I should have done exactly the same calculation we did earlier, to show you that there's a different result. But again, this was me just experimenting at the time. And we're setting C equal to typecast of variable D into an integer, and that's what C equals. So that's where this is basically coming from, is right here. So that's that statement. And then down here we go C equals A plus B times a floating point number. So the floating point value in this expression forces the calc to be done in floating point. So that's what I'm saying. If you have a floating point number, the calculation will be done, but the number assigned to the variable will still just be an integer, which we'll see down here, which is 159. Variable D, running that same calculation, and I'm just assigning it the result of that. That's what the calculation actually is in floating point. So C just gets the integer part of that, essentially. Okay, so this is why dealing with, floats and integers can be a little complicated, and converting between the two. Now, if you go over and look at Chili, you can see he's got a float here, this current wait time, and he basically it's basically assigning his variables this way. He always puts decimals in it, even if they're even though it doesn't matter. I mean, you don't have to do this. You can see that the program that I just wrote, how it worked, and this tells you it's a decimal, and that's one way of doing it. Another way would be to use, I think, Hungarian notation. Put like F cur watch time. So you're basically saying, hey, this is a floating point value, um, and that'll do it, because this does not save you from having to convert, to, between integers and floating points or anything. It's just one way of notating that your variable is indeed a floating point. But this is a lot of extra typing to have to do for that outcome. Whereas if you just put, f cur wait time, and you capitalize C, that tells you it's a floating point number always. So, um, just like it's common practice to put a little p in front of a variable to say it's a pointer, because that's actually important to do that. But I think, f, since that's another very popular data type, it makes sense to do, and even Boolean might, make sense to do, but you don't have to put I for int, because, int can be assumed to be a default value. So, that would be what I'd advise, put a little f and then deal with it like this, instead of, having to go specify it as a special deal. But then again, there are advantages to doing it this way. If you look at his colors.h file real quick, you can see down here, he specifies this as 000, with U in behind it. Okay, that U means unsigned. So that's 0 unsigned, so it's an unsigned integer basically. And here it does tell you that reference to color unsigned integer 0U, does tell you that. And here what he's doing is this is a bit shift operation. He's shifting, this value R, right here, red, by 16 bits, then ORing that with green by 8, shifted to the left by 8 bits, and then finally ORing it with B2. So that's what the function will return, in the Chili framework. But I'm not going to get into that. I just wanted to point out that, that's one of his little operations. That's not an uncommon way of doing things. I just kind of hate this always having to be point, because having to write that additional point and having to write f on it. And apparently you've got to do that. I mean, apparently. Current wait time equals 4.0. Okay, now you can do it just 4.0 instead of having to put f. They do have they don't have unsigned floating points. There's no such thing. So, but you can do it that way too, instead of having to type the little f. But I think you can also just, damn it. Okay, no, apparently you can't do it that way. You've always got to put a point. So if you want to type f, you've got to do it like that. So, but again, personally, I would just either type it that way to tell people that it's a floating point value, because it's important to know what type of variable it is. But see, what I like about, okay, when you're looking at a variable, it may not always be clear that it's a floating point, okay, because if you did a calculation like this, let's see, current wait time, plus or minus equals, god damn it, game state, for example. Okay, so that's current wait time equals current wait time minus game state. Well, it's not clear by looking, at the variables themselves, since there's no decimal numbers involved or anything. It's not clear whether these are, that you're taking a floating point number and assigning an integer to it. because the reverse could be true too. I mean, it could go game state equals minus equals current wait time, and you don't realize that it's a floating point value. So, I assume that's just a regular. I mean, I haven't looked it up. I mean, the compiler should throw up a warning when you do this, but, again, it's not clear just by looking at the code what's going on with that. And let's peek at the definition real quick and see. Yeah, it's an integer, so... but yeah, it's not clear just by looking at the code what that is, whereas if you used Hungarian notation, at least that'd be like, game state, since it doesn't have a specifier on it, would be an integer, and then current wait time, since that would have an F in front of it, is a floating point. So you're using floating point values. And two, in IntelliSense you go list it, you'll always have F, so that might help you sort it out, because IntelliSense does get in the way sometimes when you're trying to type shit in. But at any rate, I'm just saying, comment out this code block here. But I'm just saying though, that's it's up to you how you want to use floating points or unsigned integers. Because unsigned integers, that gets to be another little challenge there. Because you could put a little u, in front of I'm just trying to establish a programming style here before I get going. Something that's logical, because it is going to be an issue. Dealing with all these variable types, and Hungarian is a popular way of doing it. It just means when you name your variables, try to name them, equal to the type. So, if we took like all these, and well, I will do this. Okay, so we have it. I notice the time, 5 milliseconds elapsed. that's kind of a handy little feature. Oh, god damn it! Oh, I got lucky on that. Shit. Okay, I think that's the end of it. Let me just go do a scope out in the middle of nowhere, and then I can just define these variables in here without the compiler fussing at me. As like I said, you can put a scope anywhere, and any variables you define are only good inside of that scope. Once you leave it, it's dead. So let's do, int variable I'll just call it variable ABC. Now a short integer, if you really, short integers are so uncommon it doesn't really matter, but I guess I could just leave these fucking names the same. What difference does it make? So that's your variable A, right? Okay, and by the way, if this were a member of a class, it's not a bad idea to put M in front of it, so that means it's a member variable. So when you're working inside of a class, member variables shouldn't be public. So because of that fact, your member variables usually have a little M in front of them. That's not necessary, but usually it's good practice to do that. So your public variables don't have to, but your member variables should be, because they should be private, or often they're private. So it's just a good way of keeping track of things. Now short integer, you can go S variable A. Okay, a long integer is the same as a regular integer, so I wouldn't worry about it. Now float, like I said, put f v in front of it, and a double, you could put d v, and unsigned integer, you could put u v, and a bool, you could put b v. Okay, and a character, that's actually kind of important too. So you could either call it if you're going to do a pointer, that's how you would assign that, by the way. But a Boolean array, you could go like C array, but like I said, saying it's an array, I don't know, that's getting a little, because again, this is a pointer, this is a pointer, and this is a pointer. They're all pointers, and they can all be used the same exact way, and again, we'll get to that later. But the fact of the matter is, although this right here I'm not so sure about, I don't know what kind of a deal that would be, because it's a multi-dimensional array. I don't know if this might be different. That might be why Chili doesn't like them either, too. It might be why he doesn't like multi-dimensional arrays. Because I'm not really sure how this would behave, since it's a Boolean, okay, but it's an array that's creating a pointer apparently. But yeah, there may be some kind of trappings, because I don't know if you can. Yeah, because I mean, it might work. I mean, you might actually be able to take a pointer and assign it like that. I'm not really sure. Huh. Well, since these are both pointers, maybe I have to, I don't know, I'm assigning one pointer to another, really, is what I'm doing here. Yeah, it may have a problem with that. Let's see. Usually have to use an address of operator. Fuck. I've certainly done this before. Oh, well, the problem is that their data types are wrong. Okay. Okay, well, since that's a pointer, alright, yeah, so that works because it's a pointer, so I can just assign one pointer to the other. Okay, now the question I have is, okay, if I made this bool, we're going to have a problem again with that, but okay. Alright, so so basically it's the same type of array, and it's not because it's a bool. See, it has no problem with that, but since this is a multi-dimensional array, I can't just assign it to B. So, so that's a little caveat, I guess, about working with multidimensional arrays. It won't work quite right anymore. So that was interesting. Um, that was interesting to see. So there may be a discrepancy there. But I was going to say though that when you're defining pointers and addresses, I usually put the little pointer, the little um, pointer operator, when you're declaring the variable next to the word, because really it's a type. So we know it's a Boolean type, but it's also a Boolean pointer type. So I was getting into the habit of putting it right in the middle just to be neutral, but it definitely doesn't make sense to put it here, even though it's legal to put it there. But that suggests that you're dereferencing the operator, and it's just a little confusing because you're not dereferencing, you're declaring it. But since you are declaring it, you are declaring it as Boolean type pointer type. So it's a Boolean pointer type. So that's why it makes more sense to put it here and on functions and everything else. But at any rate, that kind of, in a nutshell is, how to deal with these various character types, and how the arrays work in the in probably a good format, for naming variables. So that's a good place to stop this video.